Hello guys, I'm Dipali Chandel and I welcome you all over here for this tutorial. So this tutorial is regarding basics of NLP using spaCy part 4. So over here we're gonna do the project text classification. For that first we have to import some modules. So we are importing some modules from here. After that you can see like I'm using the stop words from the English language and the variable which contain my stop word is stop. Now I want to see what my data is all about, right? So this is my data name that I'm reading with the help of pandas, okay, and with the read underscore CSV function. So over here you can see I have two columns, title and conference in my data. So this title represent title of the paper presented, research paper presented, and this conference represents the name of the conferences. Now, what is the shape of my data? This data contain 25,007 rows and 2 columns. Now, let's analyze the data. For that, we will do exploratory data analysis. Now, I want to see whether there are some null values in my columns or not. So, for that, I will use this function is null. Fine. Now, this is null function will give me true or false for particular rows and columns. Okay, but I want to see the total number of null values in both my columns. So I will use some function along with the is null function over here. So it is giving me 0 for this title column. That means there is no null value in the title column, and it is giving us 0 as well for the conference column. So that means there is no null value in the conference column as well. Now, what is the data type of these values? You can see 64. Fine, integer 64-bit. Now, let's see how many categories are there in the conference column. As you can see, VLDB, SCAS, SIGGRAPH, Infocom, SCAS. Okay, so like let's see how many how many we can say categories are there in the conference column. So for that I'm using an unique function. So it will give me number of unique categories. For which column I want to see? For the conference column. So I'm passing the conference column. So 5 categories we have in total. Okay. Now let's see what are those categories. So for that I will use unique function on the same column. Okay, because conference column contain all the categories of the conference's name. So these are those categories or names of the type of the conferences. Okay, now I want to see over here second row first column. As you can see, this indicate second row first column. So second row, that means this is the second row, and in this first column is this one. So this title. Okay, so you can see in the output you are getting a high performance prime field multiplication for GPU. Okay, and for this one second row second column. Okay, so second row second column, this is my second row, and the second column is CAS, this conference name. Okay, so like this we can access any of the title title of the research paper and its name of the conference where it was presented. Okay, now from the sklearn model selection module I am importing the train test split class, and from that I am using the train test split function. In that I am passing my data. Okay, along with that the test size that I am passing is 0.3. Okay, and the random state you can write anything, so I am writing 42. That means this indicate 30% of my data will belong to the test data. Okay, now this will give you two data sets. One will be train and one will be test. So for that we need two variables, train and test. Now let's see the train variable. What does it contain? So it will contain 70% of the rows. Okay, so 70% of the 2507 rows will be in the train variable. So you can see all these rows will indicate 20 over here we can see the shape 1754 rows and 2 columns will be in the train variable or train data, and in the test column we have 753 rows and 2 columns. Okay, I hope this is clear to you. Now over there, now like this we can access with the help of we can access any title or any conference name in the train and test data as well. So I am accessing for that train data in the title column. I am accessing first row. Okay, so what is the first row? This is the first row for that, as you can see. Okay, fine. Now coming to the conference column of the trained data. So in that I want to access the first row again. So that is giving me the name of the conference, www. Fine. Now we are accessing the training shape, train data shape, and test data shape. Fine. Now let's do some visualization over here to analyze the data. So we are using the bar plot. Okay, for that first we are setting the figure size. Now in the X, for the X-axis I am passing the conference column. Okay, and unique. This unique will give me name of all the categories in the conference column. So you can see those categories over here. We can see in the C. These all categories. Fine. www, VLDB, SCAS, Infocom, and SIGGRAPH. Fine. Now, moving forward, on the y-axis, I am passing the from the train data the values of the conference column value count. That will give me frequency. Okay. So, like for the www conference name, how many papers were presented? Okay. So we can see around just little bit less than 600. Okay, we can say 590 or 580, right? Now if we see for the VLDV, we can see it's around 380 or 370. Okay, now for the SCAS, we can see 350. No, not 350, it's exact 300. And like for the Infocom, you can see 280 or 270. Like this, you can interpret for the SIGGRAPH as well. Now let's see the punctuation marks in the string. Okay, so over there we imported the string over here, right? Yeah, this module we imported, and in this module, what are the punctuation marks we want to access, right? So over there I'm accessing that using this punctuation. So I got these all punctuation marks. Fine. Okay, now let's do some pre-processing on that data of research paper.csv. So for that, first of all, I will import the spaCy, and then I will load the small model of the English language. Okay, and what is the object for that? NLP. Now punctuations in this variable punctuations variable will contain the punctuation from a string module. Okay, now let's make a function to clean up the text and removing the pronouns, personal pronouns, stop words, and punctuation. So which function we are defining over here? Clean up text function we are defining over here. Okay, now over there I'm passing the docs variable. Okay, and this variable I'm making it true. Let's see what is the use of this one over here. So first of all, I'm creating an empty list with the name text, and then this variable counter, I'm initializing it with the value 1. Now I'm applying the for loop till this complete block of code. Okay, now for docs will be my complete we can say our data. Okay, now for docs, so it will access each element from that docs. Now counter, if this condition is if counter mod 1000 equal to 0 and logging is true. Now we have to look for this one. So this will complete when this will be 1000. This will be true only when then this counter will become 1000. This counter will become 1000 because 1000 mod 1000 will be 0. When we divide 1000 by 1000, we will get the remainder 0. Only in that case this condition will become true. Okay, so initialized we initialize counter with the 1. Okay, now so over here counter will, because this condition is false, so this we will not access, this statement will not get executed, only this one. Okay, and this will get execute, all this part will get execute. Okay, so counter will increase to 2. Now doc equal to NLP in the we are passing in the model, we are parsing this doc in the model. Disable, we have to disable the parser. Okay, dependency parser and NER, named entity recognition. Okay, now I am creating a list with the name of tokens, and in that list I want to lemmatize, and then I'm doing lemmatization on each token. Then I'm converting the cases of them to the lower of those tokens, and then stripping, that means removing the white spaces from those tokens. Okay, and one more condition is there. If what condition this will happen, this step will be done only and only if that lemma is not pronoun. If that condition is false, that means that lemma is not equal to pronoun. Fine. I hope this is clear to you. Okay, so if that lemma is not pronoun, then that token first lemmatization will happen, then lowering the cases will happen. After that, we will strip the white spaces, spaces which are at the beginning and at the end of the tokens, okay, or the words that we will get from the doc, and then this statement will update this tokens with those words. Now, after that, what will happen again? This that word will get processed over here along in accordance with this statement as well. So, what will happen over here for talk in tokens? If talk not in stop and talk not in punctuation. So, this tokens list will get updated only if that word is not in the stop words. That stop is, if you see, that stop is over here. Yeah, see. That means that word is not in the stop word and not in the punctuation mark. So what is our main process? We have to remove all the unwanted things. Okay. So over here we have to update our during pre-processing we have to update the list with the list of the words with those words which are not belonging to the pronouns and which does not belong to the stop words and which does not belong to the punctuation. So if talk not in stop and if talk not in punctuation. Okay, if this condition is true and if this condition is true, only then that word will be added in the tokens list. Now further, that we will get, you can see string wise in a list. But we want to, add them. So we will join them with the help of the spaces. You can see with the help of join function, and in the joiner I am passing a single space. Now we are appending this text list that we created over here, as you can see, empty list. Okay, we are appending that text list with the words in the tokens, with the words in the tokens list. Okay, now after that we are creating the series of those words that are there in the text list now. Okay, I hope this is clear. So this function will return you a series. Okay, series is automatically a list, we can say, a series of all the words that does not belong to the punctuation, that does not belong to the stop words, and those are not also the pronoun. Okay, now another function that we are creating for plotting the common words for each, we can say, each category, for each category of the conference type. Okay, so we had 5 categories. For each category we're gonna plot it. Now in that I'm passing the tag means each category we will pass. Now over there you can see this statement. So what does this statement indicate? Text for text in train conference, in that column of the conference. Okay, wherever that in that column that conference name equal to this tag, we will access its title. Okay, and in the title what we will do? Text for text in train, that title will be, all that title will be feeded in this text list. That means what will happen? Suppose I passed over here scarce. Okay, so let's look at our data. This title, first this string will get feeded in that list. Which list? This list. Okay, this text list. Fine. Then another in the conference column, for the same scarce category, the next one is this one. So again this will get added up in that list. Okay, so like this, wherever we have in the conference column, wherever we have a scarce category, the title for that will be added up in the text list. Okay, now what we are doing it over here, now we are calling the cleanup text function. So the cleanup text function is this one, that will do the further cleaning, that will remove the pronouns, that personal pronoun, that will remove the punctuation, and that will remove the we can say stop words as well. Okay, So out of this title, okay, out of this title, wherever we will have that title, we took the example of scarce. So all the personal pronouns, stop words will get removed, and that will be now that cleaned, we can say cleaned list, okay, will be in the this clean variable. After that, we are joining all those with spaces. First, we are joining them, then splitting it. Okay. Why we are doing it? Now let's see. Okay. Now let's see why we are, you know, first we are joining it and then splitting it. Okay, fine. Okay. So you can see over here, it is printing the clean. First of all, this is a list. Okay. After that, yeah, okay. Why does this is not getting printed? Now, see. Now after joining it, we are splitting it. So we are getting this one. Okay. Now again we are printing it, print the clean. So it is getting printed like this. That means first what we did, first we printed each tokens in that, that title. Okay. After that, that in the list form. After that, what we did, first we split it, then we join it. So after joining, it will look like this. Okay. Now afterward what will happen? We with this statement, now the output of this one. Okay. So this will come, the complete string, the complete title, okay, will come in a string format, okay, in the list. Fine. So like this will get execute. Okay. Now let's make it commented again. Now counts equal to counter clean. So over there in this counter function, let's see where is the counter function. I guess, yeah, we imported this counter class from this collections module. Okay. So in this counter, I'm passing this variable clean, which contain, as you can see, that output, this output. Okay, fine. So I'm passing that in the counter. Now this counter will give me, we can say, word and its frequency, in this format. Okay, so word, along with it we will get the frequency, how many times that word got, came in that title. Fine. Now we want to look on word. Okay, so let's see, in the common words, I'm executing this counts variable. On this counts variable, I'm calling the most common function. Okay, yeah, most common function. So it will give me most common 20 words. Fine. Now word 0. So word 0 means, that means the word, that token. Okay. Now over there in the common counts, those words will be updated in the common words list. Okay. Those words will come in the common words list, and corresponding frequency will come in the common counts list, because over there you can see words 1. Okay, for the top 20, most common 20. Okay, for the top 20 most common words. Okay, their frequency will come in the common counts variable. Now we want to plot these two variables, common words and common count. So in the bar plot, first we are we are setting the figure size. After that, I'm calling this bar plot. I'm using the bar plot function that is from the Seaborn library. In this X, I'm passing the common words, because on the x-axis we want the words and on the y-axis we want the common counts, the numbers or the frequencies. Okay, now we will get the plot for it. So let's see how the plot will look like for it. Yeah, let me run it again. Okay, give me a second. Okay, now we're just plotting it now. Okay, now see, sometime kernel got stuck, so it repeat the whatever changes we did, so it doesn't update it on the basis of the changes. Okay, it was giving you the output on the earlier basis, so that's why I run it again. Now over here you can see the most common 20 words on the x-axis. Okay, and corresponding frequency. So those most common 20 words are in the common words okay list, and the common counts in the common counts list. So that is coming on the y-axis, common counts coming on the y-axis, and common words list values we can say elements are coming on the x-axis. Fine. Now these all are done. So over here again we are looking at the categories which are there in the conference column, unique categories. Now we want to plot this this visualization. Okay, we are calling this function plot most common words for the complete, for all the categories which are there in the conference column. So simple, I will write this for loop inside which I will call this plot most common words, and then I will pass the tag inside it. Okay, so you can see that you will get this plot. First, this plot will be for, I guess, yeah, WW category, then VLDB, then SCAS, then for Infocom and SIGGRAPH. Okay, now let's see the test head. Okay, top 5 rows of the test data. Now again we have to do some imports. Then I'm loading this small model. Okay, and the object of that we will use. Now I'm creating a stop list and symbol list. So over there in this stop list I am I'm creating the set. This stop list is kind of a set. Okay, as you can see in the set function I'm passing stop words dot words for the English plus list of English stop words. Okay, now this will contain all the stop words from this module as well and from this module as well. Fine. Now in this symbols list, what we're gonna do, this symbols variable will contain a string punctuation. First of all we will split them with the basis of spaces, and then we will join them again with the basis of spaces. So we will get a string, of the punctuations. Fine. Now in that we are passing these punctuations as well, so that punctuation will get updated with these punctuations as well. So all the updated punctuations are now in symbols variable. Okay, now we are creating a class clean text transformer which is inheriting transformer mixin class which is already pre-built in. So let's see where the transformer built-in class. Yeah, hold on. Yeah, transformer mixin. Yeah, this is okay. So we are importing it from the sklearn.base module transformer mixin class, and we are in this class is inheriting transformer mixin class. Now in this class we have defined these functions. Now what is this transform function? First of all, in this transform function we will pass the object of the transform function itself. After that, this is x, and then these are, we can say, keyword argument. Okay, like in the dictionary format. Okay, now what it will return? It will return the output of the clean text function that we are calling it over here for text in X. Okay, now when we will implement it, then you will able to see what is happening over here. Now this clean text function is here. So we defined it over here. So what is happening over here? This clean text function gonna clean the text. So first of all, for each text in this X, okay, for each text in this X, first it will strip, it will remove the white spaces from beginning and the ending, then it will replace this slash n with the spaces, and it will replace the carriage return with the space. What is carriage return? See, suppose this is a sentence. After that, this is end of this sentence. Now to begin my writing again in the next line, my cursor should move to the beginning of the next line. This is known as carriage return, which is returning at the beginning of the next line. Fine. So this is also we are replacing with the space. Okay. Then we are lowering that text with the lower function, and then after these two updates, we're gonna return that text. So that task is being completed over here in the output of the transform function inside the clean text transformer class. Now, as you can see, I have defined one more function, tokenize function. Okay, this is my tokenized function over here. Now what does this function is doing? So over there we are passing the sample, and with the help of the object of the model, we are parsing the sample text inside the model. Okay, and that will get stored in the tokens. After that, I'm creating the empty list with the name of the lemmas. Now this will execute, we can say, for each token, each element in the tokens list. Okay, it will append it. So for each element in the tokens list, so this lemmas list will get appended with the lemmatization that is being performed in each element of the sample. Okay, each element of the sample, then lowering will be done, and then stripping will be done. Fine. Now this lemmas will be this way, this list. We are allotting this list after this appending part. After this updating part, we are allotting this list or assigning this list to the variable tokens. Now further few processing will be done on this variable token. Okay, so talk for talk in tokens, if talk not in stop list, that means these two variables that we created with some pre-processing inside them. So we have, like, if those words which are there in this tokens list, okay, is not in the stop word, is not present in the stop list, then it will get added up in the tokens over here, in this list tokens over here. Now if that word is still it is either not in symbols list, then that word will be added up in the tokens, or that that string will be added up in the tokens. Fine. Now finally we will return the token, this variable tokens. Fine. Now where we are using this tokenized function, we are using this tokenized function in this count vectorizer function. So it has a parameter tokenizer. In this tokenizer function, I am passing my tokenized text function. In this tokenizer class, in this tokenizer parameter, we are passing our tokenized text function. So we are insisting this count tokenizer function to do tokenization according to this function that we created. Okay, an n-gram range 1 cross 1. That means, what is n-gram? See, hold on. Okay, now what is n-gram? Yeah, 1 means, let's see, suppose this is a sentence, so 1 gram, that is 1 comma 1. So first it will give you I am Dipali, these three separated. This will process these 3 separately. Now what is 2 gram? 2 2 separately, 1 1, then 2 2. That is 2 grams. This is 1, then 2 2. I and M along with it, then M Dipali along with it. Okay, like this. This is 2 gram. Now similarly 3 gram will be these two as well. I am Dipali. That will be 3 gram. Okay. Now 1 1, that means we can say we are doing vectorization. Okay, for the 1 1 we can say 1 1 element. Okay, 1 1 word. Fine. Now we are creating the object for the linear SVC class, that is linear support vector classifier, that is that object name is CLF. Now in the pipeline function I am passing this clean text transformer function, vectorizer function which is the object of this count vectorizer function, and CLF which is the object of my linear support vector classifier function. Now that complete output that we will get from this pipeline after processing will be stored in this variable pipe. Okay, now in the train1 variable I am storing the title. We can say I'm converting the we can say the elements of the title column into the list format. Okay, and that list format which contain the titles from the title column of the train data will be in the train1 variable. Now labels train1 will contain all the conferences, okay, all the we can say categories of the conferences which are there in the train data in the list format. As you can see, 2 lists is there. Similarly this will be for the test data. Now we will fit this with this we will fit this train data train1 and labels train1 inside the pipe object which is of the pipeline function. Okay, so we are passing train1 and labels train1. So train1 contain all the titles which are there in the train data which are converted into the list format, and labels train1 contain all the categories of the conferences column in the list format. Now along with the help of this pipe object, now we're gonna predict for the test one. Okay, for the title column. So we will get we are storing that output in the preds. Now we want to see the accuracy. So in which 2 variables we will see the accuracy? Obviously labels test one and preds. Fine. So it is giving us 0.75 accuracy, 0.75 fraction, that is 75% accuracy. Now let's predict for some new title. So this is the title of any of the paper published in those conferences. Okay, these 2 titles. Now let's predict for these 2. So pipe predict list, I'm passing that list which contain these 2 titles. So it is giving the first title belong to SCAS conference and second title belong to this one, belong to Infocom. Okay, now we have to see the report as well, classification report. Okay, what is the precision, what is the recall and all. Fine. So first we will see the length of the prediction. So it is 753. Okay, now from sklearn I will import the matrices, and from matrices I am calling the classification report function in which I am passing the labels test1 and preds, and then in the target name I am passing the conferences.unique. Fine. So this will be, these all categories are coming from the conferences column. Now you can see precision for VLDB category is 0.75. That means out of all the predictions, 75% were predicted correctly. Out of all the positive predictions, 0.75 were predicted correctly for the VLDB category. For SCAS, for all the positive predictions for the SCAS category, 89% were predicted correctly. Similarly, 67 for SIGGRAPH, 63 for Infocom, and 65 for WWW. Now coming to the recall, so out of all the actual positives, that means which are there actual which are there in the for the VLDB category, which are actually belong to the VLDB category, 75% were predicted correctly by the model. Over here for the SCAS 85% and for the SIG graph 69, similarly 67, 65 for InfoComm and WW. Now what is the F1 score? F1 score is the harmonic mean of precision and recall. So the F1 score for VLDB is 75%, for SCAS 87%, for SIG graph 68, then 65 and 65 for InfoComm and WW. Okay. Now guys, over here we completed this project. Fine. So this is how we do text classification using spaCy. Okay. Now let's see some of the we can say cons or limitations of the spaCy library. So first of all, spaCy the sentence tokenization of spaCy is slow as compared to, we can say, NLTK. Then spaCy leaves little room for a NLP practitioner to customize the model if a particular task doesn't match spaCy's pre-built models. That means we can there's less room for the customization. Okay, and yeah, one more point we can say, it supports less languages as compared to the NLTK, and it is less flexible as well as compared to the NLTK. So these were some limitations of the spaCy. Beside these limitations, spaCy is spaCy is improving and evolving day by day, and which is making it more exciting to work with. Okay, and it is right now still it is best for production use. So guys, I hope this tutorial made you familiar with the spaCy, and I think this was very helpful for you. So thank you for attending this. Keep tuned over here. Yeah, thank you.